been told your whole life that space is a silent vacuum, a place where, famously, no one can hear you scream. But what if that wasn't the whole story? What if the universe has been singing a song this whole time, and we just didn't know how to listen? What you heard isn't a sound effect from a sci-fi movie. This is the actual X-ray frequency of a supermassive black hole at the center of the Perseus galaxy cluster, translated into a sound we can hear. It's haunting. It sounds like a ghostly choir, an ancient hum echoing across 240 million light years. This isn't just noise. This is data. This is a message. And today we're going to explore how we learn to hear it, why powerful AI is the only reason we can decode these cosmic symphonies, and how this space music is the key to humanity finally reaching for Mars and beyond. Let's get the big question out of the way first. Space is a vacuum, and sound needs a medium like air to travel. So are these sounds fake? The simple answer is no, they're not fake. Think of it like a translation. Your eyes perceive light waves and your brain interprets them as color. In the same way, we can take other types of waves, like radio waves, plasma waves, or X-rays, and translate their frequencies into the range of human hearing. NASA calls this process data sonification. Essentially, scientists take the raw data streams from incredible telescopes like the James Webb or the Chandra X-ray Observatory, data points like brightness, position, and energy levels, and map them to musical notes and tones. For instance, in the new sonification of Uranus released in 2026, higher X-ray emissions detected by Chandra are represented by high-pitched cello notes, the deep rumbling thunder you might hear from Jupiter. That represents the powerful storms and lightning strikes ravaging its atmosphere, captured as radio waves. We aren't just composing music, we are creating an auditory color palette for data. So why do this? It turns out our brains are wired for sound. Studies show the human mind is up to 10 times better at detecting patterns, anomalies, and changes in audio than it is in visual data. By listening to a galaxy, astronomers have discovered subtle gas ripples and hidden energy spikes that were completely missed for decades when just looking at the images. It's like adding a new sense to our exploration of the cosmos. We were previously watching a silent movie, and now we've finally turned on the sound. But here's where the story gets really intense. The sheer volume of data beaming back to Earth is staggering. The Mars Perseverance rover, the new imap probe studying the solar wind, and the countless satellites observing distant galaxies are generating petabytes of information. That's millions of gigabytes. It's far too much for any team of human scientists to sift through manually. This is why we are no longer just exploring the cosmos with human eyes and ears. We are exploring it with artificial intelligence. As of March 2026, the AI models we use are no longer just sophisticated chatbots or image generators. They have become our cosmic navigators. We are now using specialized AI to comb through endless streams of space noise, listening for that one specific frequency, that faint signature that might signal a distant habitable planet. Right now, as we speak, AI is autonomously driving rovers across the Martian northern rim. It's analyzing the terrain, deciding which rocks to drill, and interpreting chemical signatures that are invisible to the human eye. We aren't just sending robots to other planets anymore. We are sending minds. And what are these new minds telling us? They're telling us one clear, resounding thing. Mars is just the beginning. Now, I know what some of you might be thinking. People often ask, why are we spending billions to go to Mars when we have so many problems right here on Earth? It's a fair question, but the reality is, we go to space to solve problems on Earth. The challenges of space travel force us to invent technologies that have profound benefits back home. For example, in 2026, we are successfully 3D bioprinting complex human organs like hearts and livers on the International Space Station. Why in space? Because in microgravity, the delicate tissue layers can grow and form without collapsing under their own weight, a major hurdle on Earth. Soon, this could end organ transplant waiting lists forever. The advanced water filtration technology developed to give astronauts clean drinking water is now being deployed in remote villages, providing clean water to millions. Even the high-definition sensor in your smartphone camera was originally designed for space telescopes. But perhaps the biggest benefit of all is planetary defense. Those space sounds we talked about, they aren't just beautiful, they are a critical part of our planetary security system. By decoding the faint heat and energy signatures of the cosmos, we can track dark asteroids. These are near-Earth objects that are coated in a material that reflects almost no light, making them nearly invisible to traditional telescopes. But they do emit a faint hum of heat and radiation. Listening to space helps us find them before they find us. Space exploration isn't a luxury, it's an insurance policy for the human race. So, what's next on this incredible journey? Mars is the training ground. It's where we will learn to become a multiplanetary species. Spacex and NASA are targeting a historic crewed landing in 2028, but our vision is already set on a much more distant shore. Alpha Centauri, the closest star system to our own. The Breakthrough Starshot project is already testing the next generation of interstellar probes. These aren't massive ships. They are nanocraft, tiny probes about the size of a postage stamp. The plan is to propel them through space using a massive Earth-based laser array, pushing them to an incredible 20% of the speed of light. At that speed, they could reach Alpha Centauri in about 20 years. If we can launch this fleet by 2036, your children could be the first humans in history to see high-resolution photos of an alien solar system. We are living in a pivotal moment. We're transitioning from being a species with a planet to a species with a destiny among the stars. Space isn't silent anymore, because we, as a civilization, finally decided to stop and listen, and now I want to know what you think. When you hear the sound of that supermassive black hole, does it terrify you, or does it sound like an invitation? Let me know in the comments. And if you're as excited, tell us in the comments. Make sure to subscribe so you don't miss what's next. This is NASA Community News. We're listening. Are you?